I'll just have to be brave. When you're sending an error and you send an error with an HTTP response code of 200, I take that as, I'm sorry, but it's a really big red flag for me. I always feel that when you're designing APIs, the error codes are there for a reason.
This episode is brought to you by SignalWire. SignalWire offers APIs, SDKs, and edge networks around the world for building the realest real-time video and video communication apps with less than 50 milliseconds of latency. They use WebSockets to deliver 300% lower latency than APIs built on REST, making it ideal for apps where every millisecond and responsiveness makes a difference, like apps that need instant natural language understanding, real-time machine vision, or large-scale video and audio conferencing. Here's what makes them different. They use MCU, multi-point control unit, that mixes all video and all audio feeds on the server side and then distributes a single unified stream back to every participant. That way, every participant in the apps you ship experience the same video and the same audio. Your apps have none of the awkward audio effects, obvious lag, and jumpy video. It's all smooth, great UX, creating a more lifelike virtual experience without compromising audio or the video quality. Head to signalwire.com/video, mention GoTime to receive an extra 5,000 video minutes. Again, go to signalwire.com/video and remember to mention GoTime.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from around the Go community. Special thanks to our partners at Fastly for making sure you receive our MP3s super fast all around the world. Check them out at fastly.com. Quick heads up on this one. Unfortunately, we had some audio issues with Smiles track. We did our best to clean it up in post, but it's still a bit muddy. Please bear with us. I think you'll be glad you did. He has a ton of good stuff to say. Okay, here we go.
We are live on the tubes and welcome everyone from whatever hour of the day you are joining us. Whenever you're hearing this live or recorded. I think for once this is a European majority here, so we can say good evening. And I am joined today by my co-host Johnny, and we have two guests, and we have Anthony and we have Smile. Anthony, you are a senior software engineer at Delivery Hero here in Berlin, and you've been working with Go since 2013, and you're a co-founder of API Toolkit. And Smile is your co-founder, and you are a senior mobile engineer at Rantastic, and you also work with Go since about 2015. Welcome, it's nice to have you.
Thanks for having us, Natalie.
Thanks, nice to be here.
Okay, so what does API stand for? Let's ask the big questions first.
Huge question. No pressure.
No pressure. I had to Google that before coming to the episode. So if anybody who's listening, Googling right now, it's we get you.
So, I mean, an API is an application programming interface, but I think it can mean a lot of things, but I like to think of an API as a contract. So if you have, for example, two services, two machines, one server and one mobile application, and they need to communicate with each other, both parties can decide on this contract on, if I ask for this, this is what you give to me. You know, if I ask for this other thing, you give me this other thing. And that contract is basically what I think is an API.
Okay. Smile, what is your take on what is an API?
My take on what an API is roughly the same thing. And coming majorly from the mobile background, I would always say an API is more or less a series of endpoints that would give you resources.
Series of endpoints that will give you resources. That's short and to the point.
I like those definitions. They're very specific and sort of in terms of use, right? That's one way to use an API, right? Maybe you're making some HTTP requests. Maybe you're dealing with a different transport mechanism. Maybe you're doing it through gRPC. Maybe you're doing a perhaps fortunate or unfortunate. Maybe you're dealing with some SOAP APIs.
Hopefully not.
Hey, a lot of people, still make a living on it. So I'm not knocking it. But to me, these are sort of ways. How do you communicate, right, with an API? To me, an API is, as the name implies, right, in application programming interface, it's the interface to your functionality, to your code, right, to the behavior that you've produced and created. And perhaps it's not exposed over the web, right? Maybe you don't talk to some sort of HTTP endpoint to invoke the API. It could be as little as me creating a package in Go and basically saying, okay, what is the surface area that I'm going to allow somebody to interact with? What is that? What is the API to this package, right? And you control that through, the things you export out of your package and the things you choose not to export, right? What is internal to your API and what is external? What do users of your code get to actually use? So that surface area, to me, at its most basic, is how do you interact with something, whatever that thing is? And obviously, I'm using Go packages here as sort of the way to sort of convey that. But to me, that's that sort of at the core of it. That's what that is.
Yeah.
Even if you have like a code base, maybe just like a library or a Go package like you mentioned with a series of exposed functions. Those exposed functions are also part of the API.
So in building, right, the API Toolkit project, I'm very curious about what the sort of the company is, what the offering is. With the name like API Toolkit, it sounds like you're sort of bringing something generic in the sense of something that is a general purpose rather for APIs. Do I get that about it right? Like, what is it that you're bringing to the game here?
I mean, the two most difficult problems in computer science, and naming things and the rest. Yeah, finding names is hard, but I think this name kind of sums up a lot of what we're trying to do. We're trying to solve a few problems around APIs, and the name kind of gives it room to grow. The main problems that API Toolkit is trying to solve is around anomaly detection. So you have an API, in this case, primarily RESTful APIs, or APIs that you expose over a transport. But let's stick with the REST API. So you have a REST API with a series of endpoints, and each endpoint returns a series of fields with values, and something changes. For example, you have maybe a new engineer on the team who makes a change, and that change snowballs and just touches something else. Sometimes this kind of changes can be difficult to spot. Or even, for example, you have a legacy service which you're trying to rewrite for different reasons, and you believe you know about the contract of that API because it was very well documented. But then you rewrite that API and realize that, okay, there were some fields were there maybe 10 years ago, no one knows about them anymore, but they are part of this contract and you did not know about them. And so something breaks. So API Toolkit tries to find these issues before hopefully your customers find them.
So that's an interesting problem space. So if we can start to sort of dig in a little bit here, when I think of the operability, right, of an API, right? Say, you make something public, and once you make it public, like you said, you have a contract, right, with whoever's going to be consuming that. So making changes to that API is very hard to do, right, after you've published it, right, after you have a V1. Hence why you typically have to have some strategy for how you're going to move customers onto the next version of whatever it is, right? So the use case you give is one where maybe you have some less traveled parts of an API, and all of a sudden you think, okay, maybe can I or can I not change this or make some modification, tweaks, whatever it is, maybe even make some backwards incompatible changes. So what you're saying is that you want to have enough information about sort of the usage, how the API is used, right, in order to know what is the likelihood of me making a change and breaking a particular endpoint, right, in the sort of set of endpoints. Do I get that right?
I mean, very much, of course, within the limit of what a machine can figure out, learn about your service. It tries to understand these are the fields that are usually being sent. This is the frequency which they're being sent. This particular field, this name is usually maybe it's a string, it's a text field, and it usually has this kind of format, this kind of mask. Maybe there's some alphanumeric mask, and then there's a space and another mask. So if someone changes that name field and starts to return numbers, then obviously something is wrong. You want to ring a lot of bells and let people know, hey, this used to be a text field with this format, and now it's returning numbers.
So is this a development time tool? You want this detection before going live with a change, right?
Yeah, in production, in real time.
So before you go to production, right? Or when are you detecting? When are you saving my bacon? Like,
I mean, Smile, you wanted to add something first?
Ideally, we would all love for this detector to occur before you go to production. And definitely the tool would surely run both on your staging server and your production server and whatever servers you would have. But it all depends on the tool itself detecting these anomalies. So if you have this running on your staging environment and you've probably run tests like integration tests within your staging environment, most likely the toolkit would be able to detect such things. But if you're like maybe one of the cow persons who will probably push straight to master and deploy, like in a rodeo, then of course these kind of things would be detected on production. But that's the worst case scenario.
In a perfect world, a tool like this probably should not exist, because if people were building perfect systems, well tested, every single endpoint is tested, every single field is tested,
and everybody's following your updates.
Yeah, then you really don't need something like this. But unfortunately, in the real world, we always make compromises. People deploy to production on a Friday night, and the issues don't only come from within. So you have a service. The issue might not be that on the service side things are broken. The issue could also be that on the consumer side something is broken. For example, if a consumer used to send a particular format of input, and someone deployed a web app or a mobile app that starts sending something else, then we also want to, flag that and notify someone that, hey, this server is accepting a very different input from its clients. And the clients could be third parties, could be other companies who don't have those best practices that you are following.
Something that came up a lot during our interviews, where it's actually based on third parties. You integrated a third party provider, and I think it's also a bad practice when you version an API and you end up going back to version 1 and changing things. Meanwhile, we know if you are going to be using API versioning, if you move to version 2, you're not supposed to go back to version 1 and introduce new changes. But you constantly see third parties doing these kind of things. We won't name names, but these kind of things have come up a lot within our interviews, where you would integrate a third party, usually within payments, and you wake up some weekend or a Monday and you see a lot of requests are broken, things are not going through. And why? Because someone somewhere or some machine somewhere changed the version, an old version, and added new fields and changed old fields which shouldn't be there. So now it's not even about you making a mistake. It's more like a API you consume is breaking the contract that's been set. And within these kind of situations, you definitely want to get an alert about something like this so you could mitigate such effects.
I actually just remembered a conversation we had in the interviews with someone, and he said that they have a popular fintech provider that they consume, that they make use of. And this fintech provider probably deployed a change, and everything was broken for about a couple hours. So they lost a lot of money, but of course the fintech providers probably detected it and rolled back. But there was no public update. They did not say they did anything that broke anything, and they would not agree that they made any changes which broke things. And if you have something that shows you and says, hey, this contract broke at this time and this is what changed, you can show and say, hey, you definitely broke something and this is what you broke at this time.
This episode is brought to you by our friends at Fire Hydrant. Fire Hydrant is the reliability platform for every developer. Incidents impact everyone, not just SREs. Fire Hydrant gives teams the tools to maintain service catalogs, respond to incidents, communicate through status pages, and learn with retrospectives. What would normally be manual, error-prone tasks across the entire spectrum of responding to an incident, this can all be automated in every way with Fire Hydrant. Fire Hydrant gives you incident tooling to manage incidents of any type with any severity with consistency. You can declare and mitigate incidents all inside Slack. Service catalogs allow service owners to improve operational maturity and document all your deploys in your service catalog. Incident analytics let extract meaningful insights about your reliability over any facet of your incident or the people who respond to them. And at the heart of it all, incident runbooks, they let you create custom automation rules to convert manual tasks into automated, reliable, repeatable sequences that run when you want. Create Slack channels, Jira tickets, Zoom bridges instantly after declaring an incident. Now your processes can be consistent and automatic. Try Fire Hydrant free for 14 days. Get access to every feature, no credit card required. Get started at firehydrant.io. Again, firehydrant.io.
First time that we talked about API Toolkit, I kind of imagined myself that a good scenario for me to use that would be as a consumer of different APIs. But just now you all mentioned that this can be a great tool also for the provider of APIs to make sure that you all are in sync. So that's a very interesting accountability tool in addition to everything.
So along those lines, right? So it sounds like, and we're going to get to where Go fits into all this in a bit here. I want to make sure I understand your project before we dive in deeper. So your website, APIToolkit.io mentions observability. So observability means something very specific these days, right? It's no longer just monitoring, right? So observability implies other things. And obviously, we talked about sort of the accountability here. So I'm sure if you consume, let's imagine that I consume an API, right, from a fintech company, right? We have an SLA, right? There's a service agreement that says I can expect, this is when I should, if at all, expect outages, et cetera, right? So there's an SLA. There's a legally binding document that says this is the level of service I'm in. And then you have tools, right? Whether it be on the provider side or the client side, which obviously APIToolkit.io could be, right, something that you as a consumer or me as a buyer, right, the consumer of this API could use to basically create my own SLOs, right, around sort of the availability, right, of this API that I'm paying for and I'm consuming, right? So what does observability look like for this project? Like, are you providing tools to track over time? Like what the performance is? Like what kind of information are you surfacing with each sort of tracking that you're doing?
It's funny that you say observability is very specific these days. I actually think of observability as a word. It's just people are using it to mean so many different things. Mm-hmm. Probably API Toolkit is, joining that list. Mm-hmm. But when we say observability in the API Toolkit context, we actually mean what the word, says. It's a tool that allows you, observe both your API, but also clients and requests which are coming in and third parties that you call. Monitor them down to the field level so you can see each single field. You can see how often each field gets sent or gets received. But you can see this information over time, like you said. So you can see that the obvious API statistics, for example, that 20% of your requests to a particular endpoint end at a 404 error. But you can also see that the name field in this endpoint is a null, let's say 10% of the time, and that's something you want to fix. But you can go down to the over time and see a lot of these statistics over a period of time. So that's what we mean.
Is your focus on the shape of API requests and responses? We've come back to sort of the field and the endpoints a few times. I want to make sure that when we talk about sort of observability, we're sort of localizing sort of the word, we're contextualizing it to just basically the shape of the API, less so things like throughput and how long is the average response taking to come back and things like that? Or does your solution sort of cover that too?
Yes, I mean, we give you, your throughput, response time in different percentiles. That's kind of like just cherry on the cake. We have the information, so why not give it? But the exciting part of API Toolkit is that you get these statistics, but down to the level of the fields and the endpoints. You can pick if you have, for example, a fintech endpoint where you can accept payments, you can see that something that we're exploring is that you can see that there's an amount field which usually gets sent. You can see that this field is always being sent on this endpoint. But something we're exploring is that you would even be able to plot that amount field. So you can, on a graph, see just basic averages that this field is usually, over time, that every day, the average amount that people transact is $200. But you can just get these statistics down to the level of the fields as well. So we like to just call it field level observability, pretty much.
Okay. Right. But it goes, you have a few layers on top of that in addition to just the field stuff.
Yeah.
So I do want to sort of dig into the Go side of things. What role is Go playing in this product, right? I know you have a lot of sort of plugins and integrations, sort of, and Go is obviously one of them. But is Go playing a sort of a bigger role in this project for you?
In the development world right now, if you want to do a lot of numbers crunching and process a lot of things in little time, you have a lot of options, but in terms of the popular options, which are also easy to get into if you're gonna onboard a lot of people on the project, I think Go wins that hands down. It's a relatively simple language to onboard people into, but it's also very performant, and we use Go for a lot of this. We're trying to process our customers' requests real time, and that kind of gives us a very tight constraint, which Go is helping.
Can you think of ways that Go has sort of helped you solve a problem that perhaps would have been more difficult with a different language? Or even, did you even consider any other language? Have you used any other language on this project?
Our stack is actually, we have clients for multiple languages, programming languages, but in terms of the backend side, we mostly have Go and Haskell.
Wow, Go and Haskell. That's an interesting pairing. Yeah. Tell me more.
Which one is the front end?
A lot of the front end stuff is actually Haskell. We use Haskell for things where performance doesn't matter so much. But one of the reasons why we really we use Haskell is that for certain kinds of problems, they can be a little bit more precise to represent. I mean, you can think of API Toolkit as a kind of parser project because we get people's requests and we're trying to parse it and understand it. We're looking at the fields. We want to understand what format it is, what types it is. And this is a problem that Haskell historically lends itself nicely for. But a lot of the other things are problems where you just really need to be fast. You need to process really fast. You have constraints, memory constraints. You don't want to have 100 gigabytes memory servers. And that is where Go comes in very nicely. I don't know how the Go team did it with the Go garbage collector, but it's just really hard to beat. And you're able to process a lot of things in very quickly.
So I'm curious where your toolkit lives. Are clients routing requests through it for this analytics to be captured, or are you at sort of at the edge at the API gateway level, or where is this deployed?
So there's the ideal scenario, there's the long-term scenario, and there's the now.
Okay, yeah, let's do it.
So in the now, what we have are language middleware. So for example, in Golang, you install a middleware. Depending on if you have a web service, you install a middleware for whatever Golang router you use. And what this middleware does is that it basically takes a copy of your request and strips out sensitive information and information which you don't want on someone else's server. And then it sends this copy to our servers to process. You can sample the request, but we basically process every request that we get on the back end to make sure that that request looks like what server was expecting. So that request actually fits the contract that we have. So it's like a system that is continuously learning. The more requests from a given service we get, the more we understand what that service is supposed to look like. And if something comes which doesn't fit into this, our understanding, then we flag an issue and notify someone on that project.
Okay.
Think of it as a lawyer.
Explain more, please.
Explain.
You have two clients, and API Toolkit will seem to be the lawyer. One client doesn't have a lawyer, but the other client has a lawyer. So it's just sitting there in the middle, vetting contracts. So you could think of it that way.
Okay. So I can see how Go in this case would be a good choice as a middleware, as one of your clients, right? So if the sort of shuttling of data on requests happens, every time somebody makes a request, a new Go routine gets launched, and during the processing of the request, hopefully anything that you're doing in the middleware is not sort of delaying the actual processing of the request. So I imagine you structure it in a way that the impact to the processing of the request, right, because everything has to go through that middleware layer, the impact of for that on the request itself is minimized as much as possible. And then behind the scene, you're just sending data to your server.
This is why I told you there's the now, there's the ideal, and there's the future. So for a lot of projects, for example, Golang projects, the middleware approach works very nicely. Where the middleware is part of the project, Go's memory representation of information is very compact and quite useful. But if you're making use of a language like PHP, maybe not so much PHP anymore, but a language that tries to be stateless, then such a middleware approach doesn't really work, because you have to send each request to our servers each single time a request comes. Whereas in Go, we kind of send everything pretty much to one channel and buffer the inputs from your server and stream them to our servers.
Okay.
In some other languages, language ecosystem, this is much harder to do. So what the plan is to have this kind of sidecars. Actually, we do have the sidecars, but there's just no one using it yet. But the plan is to have this sidecar, which you can, if you have like a Kubernetes cluster or a Docker cluster, which just, instead of your application sending your request to our server directly, it sends it to this sidecar, which then, just pre-processes it and sends it to us.
Right.
That way your actual server doesn't need to keep a lot of information in memory, or doesn't need to do any processing at all.
Okay.
Or little processing.
It sounds very much like the OpenTelemetry community right now. One of the sort of the design approaches is basically to have these collectors, right, that are sort of running, and you can certainly run them as sidecars if you wished. But you can have, if you have dedicated collectors where they're, as the name implies, they're collecting all the traces and metrics and whatnot. They, on their own time, can figure out basically the sending of whatever data you're collecting to, right, your own servers, right? So you offload that processing out of the application, out of the service, right, into this sort of collector model. So that seems to be a popular approach for this kind of problem solving. So what I'm hearing is that you're hoping that even though Go makes the middleware approach good enough, that's ultimately not sort of the long-term solution, right?
I'm happy you actually mentioned OpenTelemetry. I mean, you can think of the information we are getting as traces. It's basically traces. So the entire system is very much inspired by how OpenTelemetry is designed. And the collectors, basically language specific. So if you have a Golang server, then you would have a Golang middleware, which can do all of these fancy things I mentioned. But if your server's in a programming language that doesn't have those things that makes Go great, then you have to rely on some other approach, like what you see in the OpenTelemetry world. So for collectors, outside of the collectors, on our server side, Go is the first line of contact in terms of processing these traces when they come in. That's where we actually see the real beauty of Go.
Right. For certain languages and certain tech stacks, you're going to have sort of optimized for those tech stacks.
Precisely.
Sort of collectors and things, right? But pretty much everything that you ship, the moment it touches your network, then it's all go sort of all the way down, except of course for the Haskell stuff that's sort of doing. This sounded like some sort of abstract syntax tree, like creation or something like that, trying to figure out what the shape of these APIs look like. Okay, that makes sense.
Precisely.
Hey there, it's Jared again. Have you heard about Changelog++? It's our membership program you can join to directly support our work on GoTime. As a thanks for your support, we hook you up with an ad-free feed, discounts on merch, plus some bonuses like extended episodes. Sign up today at changelog.com/++.
So talking about API Toolkit, you probably saw a lot of APIs. You probably complained about a lot of APIs in general as you were coming up with the idea for this.
Who hasn't?
So from seeing so many APIs and probably writing a bunch, what are some good practices that you see, that you follow, and what makes them good?
So being a mobile developer, I probably consume more than I create. I don't create so much per se, but one thing that's always hit me, I know this might rupture some feathers or something is, but I feel it's a bad practice. I'll just have to be brave. When you're sending an error and you send an error with an HTTP response code of 200, I take that as like, I'm sorry, but it's a really big red flag for me. I always feel that when you're designing APIs, the error codes are there for a reason. So if I request a resource, it's not there, give me a 404. If there's a problem on the server, give me one of the 500s, 501, depending on what server it is. If the resource has moved or something, I think it's a 301 or something. But don't give me a 200, then now give me a JSON and tell me error. Then you give me a constructive like error body with another error code. Even when you return like a 400 or whatever, you could return an error body with your custom code if you want that. But let errors be errors. Let response okay be response okay. For me, I think that's one of the worst bad practices. And even when you're returning JSON, returning a number as a string, it's a small thing. But it doesn't make sense. If it's a number, let it be a number. But don't put a number inside a string, or don't mask a JSON body in a string. It happens a lot. I see it a lot when I'm like communicating with third parties. I get a JSON body within a string. Then I have to encode it again or decode it into a JSON object before turning it into an actual object. I think for me, those are like one of the pet peeves when you talk within API best practices in relation to mobile development.
I just remembered one issue Smile was ranting about some time ago. I think he spent some time investigating some issue. I think there was a field that if the field doesn't exist would be a null. He was checking for this null. Maybe you want to tell the story better.
Okay, yeah. So there's this weird third-party provider we have, and when this field doesn't exist, instead they always send a null. But now when the field doesn't exist, I don't know what they do or how they do it. They just don't send the field. When you're now decoding that JSON, it crashes the adapter.
You're telling me about a situation where they were sending this null, but as a string.
Oh, yeah. So that's the thing. They fixed it. They fixed it into sending a string, and later on, they unfixed it into now sending the null. It's a stack of issues. So it seemed like for everything I complained about, they fixed it, and I don't know what really happens on the testing side. I don't know how that kept on passing through, but it kept on changing, and they were like the bane of my existence at some point, because I would come into work feeling very happy from the weekend playing game, and boom, there it is.
Nope.
And I had to do so many workarounds because of this. And I just feel things like this are terrible API designs. I mean, most times, ideally, if you are going to send in a value, which is a string as a null, that's fine. We could always check that. But removing the field completely, no, that it just makes it hacky. Then bringing it back, and instead of sending a null, you now send it as an empty string. I mean, that could still be worked, but it's just too many inconsistencies.
Yeah, they should be sending like a string to a URL of an image of a meme that says no. Nope.
Yeah.
That would make no sense.
Yes, and the part that killed me the most, I remember it now, they sent the null as a string. Yes, they sent the null, like, you know when you put a null, N-U-L-L, in a string. So instead of sending null, you send me null as a string.
Was there like a dot after the null? No.
End of sentence.
Our users were literally getting null. They were getting null when you display the text. You were getting null. And I saw these things and I was like, how? I didn't believe I made that kind of mistake. And I couldn't for the life of me understand why I was displaying null. I just couldn't get it. When I had to go through the response, I now saw a string null. And I was like, okay, that's nice.
That did not live up to your namesake. Did not put a smile on your face.
Oh, no, it didn't.
Oh, man. Given that you're probably receiving a lot of your sort of the data you need to process in JSON, correct me if I'm wrong.
Yeah.
How is it dealing with JSON in Go? Do you find like the standard library works just fine, or have you had to use something else?
Go actually handles JSON quite nicely. Unfortunately, most programming languages in the world are not written in Go. So this makes it quite difficult to work with. For example, in the non-strongly typed, in the dynamically typed ecosystem, it's very common to have one field that can be three things. Maybe it's an object sometimes, other times it's a string, maybe sometimes it's null. And this is relatively difficult to represent in Go. You need to maybe use an empty interface and kind of go through it. So this problem, it kind of makes it harder to consume APIs in Go. It's really nice to produce in Go because every language would get who consumes an API that was made in Go would get something very consistent. But if you as a Go service is the one consuming, then you need to be prepared to deal with these things that are very difficult to represent in Go. Unfortunately, we outsource a lot of these kind of problems to Haskell. The language just exists to solve this kind of parsing problems, and it's just more mature in solving this kind of parsing problems than Go. Definitely, these things can be done in Go. You can save it into an interface and have a cast and go through a list of possible alternatives. But the solutions are just easier in Haskell.
Right. So I'm assuming that in the sort of the next iteration of the product, where you do have a separate sort of let's just go with the term sidecar for now, but you do have a separate collector, if you will, right? Then the constraint really becomes how fast can you show sort of the results of your analysis of your anomaly detections, right, in your own dashboard, right, and not how fast you can process or how fast you can get out of the way of a particular request, right? Then would you say that it doesn't matter as much how fast the processing of the JSON is if you are collecting and maybe doing some compacting on the collector side, maybe doing some sampling right before the data even reaches the edge of your network? Would you say that the processing JSON at that stage doesn't really matter? Or do you have a similar concern?
So what we're doing actually, I mean, you can divide the problem that we're solving into two things. One is that we're building a model that represents the API. And the second thing is that we get a stream of APIs and we're comparing each item in this stream against this model. So this is kind of the validation process. So this working with this stream and comparing is what we're doing in Go. But building this model, which we're then going to compare against, is just what we're leveraging Haskell for. And processing the stream is where a lot of the anomaly detection happens, because you want to, go through the traffic in real time, and if there's an issue, you want to alert someone. But in terms of building the model and displaying it on the dashboard, that's something that there's no real time constraint. I mean, there is a time constraint, but it's just more flexible. You don't need the most performance thing to display this model on a dashboard, for example. But you need the fastest thing you can get to, if you want to process, for example, if we have customers who are maybe doing a million requests per second, we need something that can actually process 1 million requests per second. Basically process it and compare it against the model and say, okay, is this request valid? Yes, then throw it away. Is this request valid? Yes, throw it away. Pretty much that.
The API toolkit is available open source on GitHub, right?
Right now,
It's like, well, what happened was,
it's a business. The middleware, like the Go middleware, is on GitHub, but we are just slowly rolling things out. Actually, right now, it's API Toolkit is in a closed beta where we're testing with a few companies, and we're just going to gradually test with more companies on our waitlist. So, I mean, there's a waitlist people can join. Over time, we're sure that we can handle whatever our customers throw at us. Because if you think about it, we need to be able to handle the sum of the traffic from all our customers. So if we have one customer making 1 million requests per second, another making 2 million requests per second, we need to be able to handle 3 million requests per second. So we're just gradually making sure that we can handle them.
unless you sample, baby, you gotta sample.
Yeah, that's the problem. I mean, we eventually would encourage sampling, but we need to be able to handle situations where there is no sampling, because you never know where an issue would be, right? The issue could be in the request you sample out. So that should be a decision which the users of API Toolkit make for themselves.
Yeah, that sounds like a business decision. You can kind of punt that down the road a little bit. Cool. So given that the project has no open source components, how would you say the community can help you, if at all? Or is it not at the stage yet where you can get the help from anybody?
Yeah, I think it's actually not so much at that stage yet. We are going to get to a point where we would need clients for most languages out there.
You need help with getting clients?
I mean, that's something that we would figure out when each new language that we need a client for comes up. But yeah.
Okay. So clients for languages, not customers' clients.
No. Clients. Okay. Collectors, precisely.
Got it.
I mean, okay, customers, cool. Clients, customers, that is always welcome. No one says no to clients. But yeah.
Fun. Okay.
Is it that time, Natalie?
It is. It is the time.
Here we go.
Time to invite Matt.
Matt?
I actually think you should probably leave.
Okay, now that we had Matt Sung with us, we can officially approach the second part of the show in the last 5 minutes. So, guys, we are interested in your unpopular opinions. Who would like to go first?
I don't know. We heard some from Smile. Well, I don't think they're that unpopular. He raises some fair points. Don't send the null strings in your responses.
Use the HTTP codes.
Oh no.
Use the HTTP codes.
Yeah, please always use the HTTP codes. They're there for a reason.
So, but what is your actual unpopular opinion?
Okay, it's not really API or tech related, but it's more of educational. It's more like I think the current school system, or the school system that's always been just doesn't work. You subject children to, like, I don't know, is it 8 hours, 10 hours in school with 15 to 30 minutes break? Then they come back home to do 2 to 3 hours worth of homework. They're like bank workers, or no, it's like the kids are basically in this reform sweatshop that you pay for. That's how I see it. Yeah, you send your kids to a sweatshop and you pay for them to suffer. Because, I mean, they're children. Okay, like you have a full-time job. You work like 8 hours. When you're done, you're tired mentally, you're stressed. Then imagine children having to go for like 8, 10 hours outside their home. They come back and they have another 2 to 3 hours of assignments. they have no life besides school. Like, we don't build children's character. So I really think the school system should be modified in a way. There are shorter times, focused learning. And I think there was a study where children who are homeschooled actually perform better than kids who actually go to the traditional education systems. So that's my unpopular opinion. I don't
Were
know.
you scarred by this growing up?
Oh yeah, I hated homework, to be very honest. I did it, but I hated it.
It's almost like we're training our children to go into some pre-existing system where they go to work 9 to 5.
Oh,
Yeah, we're training workers, aren't we?
Yep. We are. We're training, we're giving them, it's a stress test.
Yeah.
Can you handle what's gonna come for you after school?
Yeah.
Yeah.
All right. Well, I don't know if that's gonna be unpopular, man. That's I don't disagree. I hear you.
I definitely agree. I think I saw a talk by Ken somebody, sorry, I don't remember, a TED talk, and he was like, kids who want to go into kindergarten get interviewed. And it's like, what exactly are you interviewing these kids for? Like, are you gonna ask them, what have you done with the 3 years of your life? Just breastfeeding?
I don't know. Pee, poo, try to walk around. I mean, I don't know.
Show me how you use the touchscreen. When you open and close apps.
Yeah.
Someone said something like, he saw an advert that said college begins at kindergarten. And he was like, what?
Good Lord.
Kindergarten begins at kindergarten.
Yeah, I think it was that same talk.
Right. From Ken from TEDx.
Yeah, that
guy. Shout out to Ken from TEDx.
Anthony, what's your unpopular opinion?
Mine is just that I actually think German as a language is quite nice. I have been in Germany for 3 years and have been avoiding the language until this year. And after some months of classes, it just makes so much sense. The rules are so... I can't imagine learning English if I didn't learn it as a child. Because when I think of the rules in English, like, there's almost no rules. There's exceptions of exceptions of exceptions. And in German, it just makes sense. So, yeah.
Okay. For lack of a better term, you were afraid of it until you started learning it.
Yes.
Yeah.
And I mean, there's this popular stereotype about the German language. It's like machine.
Harsh.
Yeah, so harsh. So, but I mean, maybe that's also what makes it nice, because then the rules are very clear.
Mm-hmm.
Until you hit exceptions.
So
But there's probably less than in English. I think I would agree with that.
I hope. I'm still learning.
Yeah, well, let's see. So your unpopular opinion is that German is actually nice.
Yes.
I will be curious to see how is that going to vote out.
We'll see.
Yes, you can think of it also as a sort of a contract, sort of an API, right?
I know.
Languages.
Yeah, my API contract with the German population. With the ladies at the Anmeldung office. At the Burger.
City registration and all the bureaucracy. It is a serious contract with them. They will not upgrade to version 2.
Yes, they will not.
Yeah.
Cool. All right. Well, thank you very much for joining. And thanks everybody who tuned in. And we'll look forward to hearing about your contracts with the world, I guess, and all the text.
Yeah, good luck, guys.
Thanks for having us, guys.
That is our show. Thanks for listening. What do you think? Let us know in the comments. Yes, you can comment on this and every episode of Go Time on changelog.com. There's a link to the discussion thread for this episode at the top of your show notes. If you haven't subscribed to the show, now is the time. Head to gotime.fm for all the ways. And if you're listening in a podcast app, shoot us a review maybe. Go Time is produced by me, Jared Santo, with music by the mysterious Breakmaster Cylinder. Thanks again to Fastly for ensuring our shows get shipped out super fast all around the world. And to you for being a part of what makes Go Time awesome. We appreciate you spending time with us. Next up, John and Matt are talking GraphQL with Mark Sandstrom and Ben Kraft. It's a good one, so stay tuned. We'll talk to you again next time on Go Time.